In data structures and algorithms, we have three major problem-solving methodologies. The first one is what we refer to as divide and conquer. We also have a second one, which is brute force. And the last one is greedy, let's just call it greedy algorithms. These are the three major problem-solving methodologies. Divide and conquer is self-explanatory. This is where you have a problem, you break it down into some sub-problems, you solve those sub-problems and match them all together later on. Then brute force is where you basically try every possible solution that is there. And greedy algorithms is where you make the most optimal choice at every step of the way. It doesn't mean that the final step is always going to be efficient. But I'd like us to quickly look at divide and conquer. So let's say this is the major problem that you have, right? And what you do is you need to divide it into sub-problems. So you can have major sub-problems here. And all of this, they of course stem from the main one. Then you end up solving this and you solve all of these sub-problems recursively. And once you've solved them, you basically merge. This is where you solve them recursively. Then you have a solution from all of them. And this final solution is what you present as the solution to whatever problem that you had. I'm going to use a simple example of divide and conquer algorithms. When you talk about divide and conquer, I'd like you to think of search. And when you talk about search, we have a method known as binary search. This is how binary search works. In binary search, you'll have a list. So you'll have a list of, let's say you have a list of numbers that is sorted. So 1, 2, 3, 4, 5, 6, 7, like that. And when you have this list, you want to, let's say you have an element that you're searching for. You are searching for, let's say 5, right? What you do in binary search, you set up 2 pointers. You're going to have a left pointer and you also have a right pointer. Once you've set these pointers, you find a middle element. The middle element is simply a middle index of all this. So the middle index here would be, let's say, of course you have to calculate, but in this case, our middle index is going to be 4. This is the middle index. Let's call it like that. When you have the middle index, the next step you do now is you take the target element that you had, right? So let's say we had a target element. This target element could have been x, or in this case, we know our x is 4. Now you compare between the left pointer and the right pointer, where does the target element fall under? If the target element does not fall under this left bracket here, then you basically discard that, and then you remain with this right bracket. This is where you start dealing with that. You also look at the middle element, and you compare this with the target element, and then you end up finding that this is the element that you are looking for. But if the element you're looking for was a lot further down there, then all you do is you shift this left pointer. So you find that the left pointer shifts here, and then you continue with that process again recursively until you get to find the element that you're looking for. It be 6, it be 7, whatever element. But that is what divide and conquer do look like. If you want to learn more about this data structures and the algorithms in a better and more visual manner, I'd like you to just head over to my YouTube channel. You can search my name on YouTube and go and learn all this. I have an entire playlist on data structures and algorithms. Happy coding.